Welcome to Fun with Fluid Dynamics. Episode 1, Pressure versus Friction. Do you like to build stuff? Want to go fast? Really fast? What would you say if I told you that sometimes this shape is better if we're going fast than this shape? To explain why, we gotta start with a brief overview of drag. Drag is the force in a fluid, in this case the air, that applies to an object in order to stop it from moving. It does this through two methods, friction and pressure. Friction is a force that opposes motion through contact between two objects, like this block and the ground. But if you have a fluid that doesn't have a lot of friction, like air, the other way the fluid can stop the object is through pressure drag. Pressure drag is created as an object moves through a fluid. As the fluid moves around the object, if it's not able to fully come back together, it makes a pocket of low pressure in the back. So when fluid moves over a more streamlined object, like an airfoil, the increased surface area gives the fluid more time to come back together. This creates a smaller pocket of low pressure and thus reduces drag. To show this, let's do a quick experiment. Here we've got a mini screwdriver and a small weight falling through the air. Because the air doesn't cause a lot of friction, the screwdriver falls just a little bit faster. Next, we have the same screwdriver and the weight falling through water. Now, because the friction forces are important in water, it slows the screwdriver down to nearly the same speed as the weight. Also, you can see the separation of the water behind the weight, and that looks really cool in slow motion. And lastly, we have the same screwdriver and weight falling in corn syrup. Now, because corn syrup is a lot more viscous than water, the friction forces are really important. So the extra surface area of the screwdriver, as you can see, slows it down a lot, and the weight falls much quicker than the screwdriver. So when you have a fluid like air, you're able to move faster with the streamlined design, but if you have a fluid that is more viscous or that is hard to move through, the friction forces will be more important, and more surface area will slow you down. So how do you know when you need less surface area? It all comes down to something called the Reynolds number. The shortest sum up of the Reynolds number is that it helps you to know how friction and pressure are going to affect your fluid. Basically, all that you need to remember right now is that if your Reynolds number is big, then you'll want to use an airfoil because the friction forces won't be as important. But if your Reynolds number is small, then you'll want to use more of a rounded shape that reduces surface area. So that's it for today's little lesson about the Reynolds number. Obviously, there's a lot more to it, but hopefully this gave you a little bit of understanding about friction and pressure and how that affects objects moving through fluid.